In this example, we're going to be taking a look at graphs of basic polar equations. First, we're going to convert each to a rectangular form, then we're going to graph. We'll also compare that with the polar graph. So if we convert this one into a rectangular coordinate equation, what we're going to do here is we're going to square each side. So I'll have r squared on the left and 2 squared on the right. So r squared will be equal to 4, and we can replace r squared with x squared plus y squared. If I graph x squared plus y squared in rectangular coordinates, this is going to be a circle with the center at the origin with a radius of 2. So I can plot a few points right over here and right here. And draw kind of a circle. There we go. Looks a little circlish. What I'll do now is I'll go through how you can graph this actually in polar form. So if we didn't even convert this into rectangular, could we still graph this? And the answer to that is definitely yes. So when we do that, we're going to look at this r is equal to 2 without squaring anything, just right here at the original r is equal to 2. I can make a table if I want to. I'll put theta here. That's usually our independent variable. And then r is our dependent variable. So I can pick a value for theta, or an angle that I'd like. Let's go with 0 radians. Now, if we think about what this equation means right here, it means the radius is always 2. And there's no theta to substitute in, so my radius has to be 2. Also, I can pick another angle, let's say pi over 6. And that's the same as 30 degrees if you're thinking about that in your head, where that angle would be. And the radius there is also 2. Now, if I want to start plotting points, I can do that. Maybe I should have done that for the previous one. So 0, 2 would be an angle of 0 and a radius of 2. Pi over 6 would be 30 degrees, and that's also a radius of 2. So that might be right about here. The line that we see just above is 45 degrees, or pi over 4. So we could even try that right now. Here's pi over 4. It kind of looks like a 9. Let me try to write that a little better for you. Erase that. So we've got pi over 4, and the radius there is still 2, so I can put another point here, and you might be kind of seeing what pattern is occurring. We can pick other values for theta, like pi over 2, that's 90 degrees, so then we would go straight up and a distance of 2 away from the center or the pole. And then you could pick other ones too. You could do like pi, which is 180 degrees. Once again, the radius is 2. We could do 3 pi over 2. The radius is 2. So if we plotted those points, we would wind up with pi comma 2 here. And then also we can go to 270 degrees and out 2. And that should have been 2 comma pi, I guess. So if we plotted every single point, we would actually wind up with a circle right here with a radius of 2. Now, that's the exact same thing that we had over here. So actually, when we graph these polar equations, same thing, they will be the same as the solutions to the rectangular form. All of those points or those ordered pairs will form exactly the same graph.